Now let us try to solve this piecewise defined function question. So f(x) is equal to minus 2 if x is less or equal to minus 3. So let's label this as equation number 1. Then let's now focus to the equation f(x) is equal to minus 2 if your x is less or equal to minus 3. So later on we will graph this. This is just a constant function. Let's see the second equation here. This is f(x) equal to modulus 3x plus 1. So the domain of modulus x here is now less than 3. So we need to open up this by using definition, which is using the mirror technique. So modulus x is less than 3. So this is your modulus. When it is less than 3 not included, this will be more than minus 3 not included. So this is the answer. Let's look at number 3. So this is equation number 3. So what do you have here? f(x) is equal to 8, another constant function, and right now your x is more or equal than 3. So now let's graph the first one. f(x) is equal to minus 2. So let's draw x-axis, y-axis, and also origin. Now let's focus here. You want to draw f(x) is equal to minus 2. So this is just a straight line here. And then let's name the coordinate here as minus 2. So what do we want? We want the endpoint part, which is x less or equal to minus 3. So let me write here. When x is minus 3, your y is still equal to minus 2. So let's see, where is the graph? Minus 3 somewhere here, minus 2 is down here. So included or not? Yes, this is included. Okay, so make sure you know you want to include this. So this is minus 3 minus 2. And then transfer the point. Then transfer the sheet. So now let's transfer this to your final answer. Let's start with this point here. So this is minus 3 minus 2. So let us write here minus 3 minus 2. So this is included. So you transfer the point, minus 3 minus 2, then transfer the graph. Okay. Let's proceed with graph number 2. So this is a bit difficult because you've never done this before. So let me show you how to solve f(x) is modulus 3x plus 1. Okay, so the trick is, first of all, let's just draw without the absolute value, meaning that let us graph what is 3x plus 1. So now let's just use the two endpoints just now. So it is 3 and also equal to minus 3. So now when your x is equal to 3, let's substitute here. So it becomes 10. Another one, when your x is equal to minus 3, this will be equal to minus 8. When you have put the point 3, 10 and minus 3 minus 8, therefore just connect, you'll find a straight line. So now we want to find modulus of 3x plus 1, meaning that we don't want any negative value here. We just want to put a mirror here, and then whatever number here just reflect upward. So let's see what will happen. This is just going to the upper part. So since this acts as a mirror as well, if this is minus 3 minus 8, what is this number now? This is minus 3, 8. So we can delete it because we already have the reflection going to the upward. So now let's see, we want the point from minus 3 until 3. So these are the 2 points. Let me highlight it for you. Okay, and make sure it is not included. So since it's not included, this should be a hole. Okay, so now let's transfer the point. The first point is minus 3, 8, and then another one is 3, 10. Okay, so 3, 10 is somewhere up here. So in order to find this value here, just let your y 3x plus 1, make it equal to 0. So when you want to solve this, x is equal to minus 1 over 3. Okay, so this is minus 1 over 3. So make sure you bring it together as well. So let's draw the first one, 3, 8. Second one, this is 3, 10. And you also have minus 3, minus 2. And now we want to fill in this one here. So this is minus 3, 8 already done. And then 3, 10 already done. Only this part here is not ready yet. Okay, so what is this part here? So this is when your x is equal to minus 1 over 3. Now let's connect all of the points. So now let's proceed with the third one. Now let's see the third one, the final function fx equal to 8. So this is just a straight line, okay, a constant function. But now we know x must be more or equal to 3. So the coordinate later on will be 3, 8. And then let's label one line like this. And then this is 8, right? Okay, so now what you should do is you must take 3 and above. Okay, so 3 and above, the coordinate is 3, 8 right now. So let's find 3, 8. Okay, somewhere here, included or not? Yes. Okay, so we want to take more or equal to 3. So we are talking about this part here. Make sure you highlight it. Let's transfer now to our final answer for piecewise defined function. So the coordinate of 3, 8, this is included. So let me show you 3, 8 is somewhere here. And just transfer the line. So this is just a straight line, so be careful. And then since this is the last one, let's put in the arrow here. So now we have finished answering the piecewise defined function. Okay, what if you were asked for the domain and also for the range? Okay, let's see for the domain, which is x. This is all included. Up until here, this is not included, but this is included. You can still go on. Okay, so this is not included, but this is included. So let's continue until infinity. So x here is all real number, or you can write as minus infinity until infinity. Let's see the range. So you don't have any other value of graph here, but this is just one point on the graph, which is minus 2. Alright, so your y will start from there. Only minus 2 alone. So put it in bracket. So union, again, you don't have any graph, and then we will start here. Since we'll start here, now our y must be starting from 0 included up until 10, and then this is not included because you can see here this is a whole. So that's it. This is for your domain, and this is also for your range. So that's the end of this video here. Assalamu alaikum wa rahmatullahi wa barakatuh.